Today we'll be going over how to make a third-person controller for mobile systems, so you'll be able to look around the player by swiping up and down at the top half of the screen. You'll also be able to move around by using the joystick, and you also have this button to press to jump around, so you can look around the player, and when you start walking again, it'll face to look in the camera direction. And you can also test this in the Unity editor. Right now I'm using the WASD keys and the jumping keys, and I'm using the mouse to look around the player. So that's one of the benefits of the input system, is that you can easily change between devices to be able to test with barely any additional work. So let's get started. I'm using 2020.1 version for this tutorial. It's the newest version that just came out. There's a couple of things that I've done to prepare. The first thing that I did was go to File, Build Settings, and I switched my platform to Android. And if you don't have the Android installed, just go to your Unity Hub screen and then Installs, and then go to the version that you're currently using. You press these three buttons, Add Modules, and then you will be adding in the Android build support, the Android SDK and NDK, as well as the OpenJDK, and it will automatically set those values in the Unity editor so that when you build your game, it will use these tools. And if you're using iOS, you do the iOS build support. This will build it to Xcode, and from Xcode, you're gonna export it to your iPhone or iPad. So right now you can see I have my LG G5 connected here. Make sure that your device has development mode running. It can differ for each device. I recommend looking online how to enable developer mode on your phone. And you also have to connect your phone to your computer via a USB cable. And make sure you give your computer access to your phone. So when you plug in your phone, for example, on mine says, allow this computer access to this phone. I just click yes, and then you'll be able to build stuff onto your phone. Another thing that I did was go to Window Package Manager. And in the new package manager, you have to go to Unity Registry, and it will show all the packages in the Unity system. So I'm using the new input system, which just came out of preview and is now verified. I downloaded it down here. I just pressed install. And after a while, it tells you to restart the editor. So you just click yes, and it will restart the editor. And another package that I installed was Cinemachine, which is the camera movement system that Unity made, and we'll be using that for our tutorial. And lastly, I'm using URP, Universal Render Pipeline, which I just selected it when I started. So when I clicked on New Project, I just selected URP right here, and it comes with this default scene with the post-process volume. That's why it looks so nice. And then I just added an empty game object for my player, and then as a child I added in a capsule so we can actually have our player. And there's a reason that I'm making the player an empty game object and the capsule have the mesh on it, and I'll explain that later. And then I just made a cube as a child of the capsule as a kind of like a little VR headset so we can see where the character is facing. Alright, so let's get started. So I'm going to make a folder here, right click, create folder. I'm just going to call it sprites. And I'm going to be importing this white circle PNG, and I'm going to use that as the joystick. So in the texture type, we want to go to sprite, and then I'm just going to set the compression to none so it doesn't compress the quality, and I'm going to click apply. And so now you can see the white circle PNG. And you can actually get this through the input system. So if you go back to the package manager and go to input system, they have under their samples, they have a touch samples right here. And it has 4 different projects inside of it using mobile touch system. But my moderator for my Discord channel found out that when you import that samples, it will change your physics collision. So in here, it will remove default collision. So I just want to make you aware that if you're using the samples, make sure to enable your collision or else your collisions will not work. Alright, so let's make a UI so we can have our joystick. So let's right click UI and let's create a canvas. And for the new input system, we want to go to our event system, and we want to click this button here, replace with input system UI input module, so I can use the new input system. Then under canvas, let's right click, create UI image, and I'm going to be using that white circle I just imported, so just click that little button right here and click on the white circle. And then we're going to want this to be on our left side at the bottom. So we can click this anchor presets, and it will anchor it to a certain part of the screen. So when the screen size changes, it'll keep its relative position. So we want to anchor it to the bottom left. And we also want to set the pivot to the bottom left, because once we do that, the starting position will be down here at 0, 0. So we can press Shift And we're also going to want to press Alt. So right here it says set pivot for Shift and set position for Alt. So then we click the bottom left and it will set it here. And now you can see that since our pivot is at the bottom left, we start at position 0 and 0, and it's at a good position. And then let's just move it. And then let's just move it by 50 to the X and then 50 to the Y. And then I'm going to go to the Open Emoji site, which has really cool open source emojis, and I'm going to download this white circle as a PNG. I'm just going to drag it into our sprites, and I'm going to make the same process. So texture type, sprite, and then compression to none, apply. And then under our joystick, which I'm going to rename Joystick, I'm going to make a new UI image. And I'm going to put in the new sprite. And for that joystick, I put the max size to 64, so it made it a little bit more blurrier, so it can blend in better with the other sprite. And then in the rect transform, you just set the pivot to the middle, and it's already there because it's a child of the bottom left, so it'll move with the joystick. And then this is the actual joystick that will be moving. And let's set the scale to 0.5 and then 0.5 so we can make it a little bit smaller. And then I'm just going to make another UI image. And I'm going to put it to the bottom right, so press Shift and Alt, bottom right. Put the position to -50 for the X and 50 for the Y. And then for the source image, let's put in that same button. And I'm going to put the scale to 0.5 and 0.5. So I'm going to put the position Y to 60 so it looks a little more aligned. You can play around with the values. So you see when we expand our game, the buttons move according to the screen. Alright, so let's actually get started with the movement. So let's go to Assets, Scripts, and let's make a new input action. So right-click, Create, go all the way down to Input Actions, and let's call this Player. And I've made several videos on the input systems, so if you're interested in learning more about how this works, I'll put it in the description. And let's make a new action map. I'm just going to call this Player Main. And then we want to have 3 actions. We want to move around, we want to jump, and lastly, we want to look around. So rotate around the player by swiping. So I'm going to put the action type to value so we can select the control type, which is vector 2. And for jump, we just want that button, so that's fine. And for look, we want to have also a vector 2. So for our move, let's expand it, and we want to set our binding to a gamepad left stick. And this is really interesting because the input system comes with a joystick that we're going to use. And then with that joystick value, you can override any other value that you're using. So in this case, we're going to override the joystick for the movement with the left stick of a gamepad. And then you can actually use a gamepad with your iPhone or your Android device and it would work the same. And we'll also add in a binding, a 2D vector composite to use for our WASD keys so we can test it on our keyboard. So we can listen on the path W, we can press down, listen S, left, listen A. I'm just setting the WASD keys here. Path, listen, right. So D, WASD. For our jump, we only need one binding, which will be our spacebar, so we can actually type it in as well. So you can press spacebar here, and we're going to override that with the input system. And for our look, we're going to put our look to the right stick of a gamepad, just like you would do if you're playing an FPS shooter. You move with your left stick and you look around with your right stick. And then we can just save that asset. And we can click it and generate C# class, apply. So then we can use this script in our player controller. But before we do that, let's actually override those values. So we can go to our joystick. So we can click our image joystick and then we can add in a new component. And we're going to add in an on-screen stick. And so the input system comes with this on-screen stick where it has this movement range and a control path. We can open it up to take a quick look at it. So here they're adding in an on-screen stick component to the menu so you can put it on your component. And then they implement a couple of interfaces here. So these are the UI interfaces. So whenever you're clicking down, you're clicking up. And then whenever you're dragging something, they have events for that which you can implement. and they're implementing those functions right here. The main thing they're doing is deriving from on-screen control, and this is what allows them to override those input system values. So for example, here on pointer down, first they get the position of where you're pointing down and they store that. Then on drag, they're calculating the delta while you're dragging. So they're taking your current position and subtracting from where you press down, which they set up here on the on pointer down. You can see it says out and pointer down here, which means that they put in that value into that variable. They're clamping that delta value. They're adding it to the start position, and then some more math. They send the value to controls. This is the important part. This is where we'll be overriding the gamepad controls by sending in the values from this script to the input action. And same with on pointer up, they stop the dragging motion, and then some extra fields here. And it's very similar with the button as well. So we can now select a control path, and we can go to gamepad, and since this is our movement, we can say our left stick. So it will override the vector2 value for the left stick. Then for the other image, which I'm just going to rename to jump, I'm also going to rename the other joystick to move. I'm going to add in an on-screen button. And same thing, we can do the control path. In this case, I'm just going to say space. So we're going to override that space. And you can also, for the jump, you can add in another binding if you wanted to use a gamepad. So you can say gamepad. You can choose any button you want. You can say button self for the jumping. So now when you attach a gamepad, it will use those controls. And then finally, this is the tricky part. We're gonna use the joystick to actually rotate around the player. So let's add in a empty game object. I'm gonna put it to the top of the canvas so it will not appear over the other two buttons. And I'm gonna rename it to look. And then let's just add in an image. We're going to set the anchor to the top. So Shift and then Alt. All right, and then let's set the width and height. So let's try 1000. And then let's go with 350. So this is the area that we'll be able to swipe to look around. And for the image, we don't actually need the image, we just needed the rect transform. So we can disable the image, but I'm just going to click on the color and put the alpha all the way down to 0 so it won't be appearing. And then add in another on-screen stick and change the control path to gamepad right stick. So if we actually press play, we can actually move the joystick around. Nothing will happen because we have to program that. We can also press the button, and you see when we're moving around the top part, that image is moving around with it, but we won't be able to see that. We're just getting those drag values for when we want to look around the player. All right, so let's implement that movement. So right click, create C# script, player controller. And then we're gonna make this easy for ourselves. So let's go to our player. Let's add in a component and let's add in a character controller. So Unity already has a character controller for you to use. It's physics free, so it doesn't depend on physics. It implements its own physics, and we can actually send values to it and it will move our character accordingly. All right, so I opened up that script. I'm just gonna delete these comments and let's activate our input system. So private player input. Then in our awake, we can say player input equals new player. We also have to have it on enable. Player input dot enable. We have to enable our input action. And we also have to say on disable. So whenever this script is disabled, we do player input dot disable. And so luckily, Unity has done a good amount of work for us. So I'm going to link this down in the description. Under their documentation for charactercontroller.move, they have a script that actually does what we want to do. So we're just going to copy that script because that's what good programmers do. Because you don't want to rewrite stuff that already exists and is free to use. Unless you're doing it for learning purposes, then that's another thing. So right there we have everything we want. Let's delete the start and update. And let's just paste that in there. So for our start, it's adding in a character controller. So we don't want to add in a character controller because we already added one in. And then we have these variables that we're using here. This one keeps track of the character controller attached to our game object. The player velocity is going to be used to keep track of our current velocity. Grounded player will be used to, check if our player is grounded, which luckily the character controller does for you. And then we have some variables here, which I will just add in a serialized field to all of them so we can change those values in the inspector. So we can mess around while we're playing the game, and then if we want it to be faster, we can do so. All right, so now we want to adapt this to use the new input system. So the first thing we're saying is the controller grounded? We're just storing that in the grounded player value. If the controller is grounded and the player velocity is less than 0, then just set it to 0. We don't want to have a force going down on the player if it's already on the ground, because if you do, it'll look a little glitchy, like as if it's trying to go through the floor, but it won't quite go through the floor. Then here is where we want to change it. It's getting the old input system, so let's change that. Vector2 movement input equals, then we can just say player input dot our action map, which is player.main dot our action, which is move dot read value, and then let's read in our vector2. And I misspelled movement here, so I'm just gonna change that. And let's remove this line here, vector3 move, and we're gonna make our own new vector3, which we're actually gonna change later. But for now, to test how this works, we'll just be using the old way. So movement input.x, 0 for the y, and then movement input.y. So we want the y to be 0 because this is going to be our jumping, and then we're gonna be moving on the x and the z axis, because in Unity we have the blue is the z axis and the red is the x axis. So we want to move along these two axes, and when we jump we want to move around in the green axis. All right, and then we just replace that value. This is just setting the forward position to our movement, so this will rotate the player in the way we're moving, which we're not going to use later on, but for now we'll just leave that. And then here, get button jump, let's replace that. Player input dot our action map, which is player main dot jump, and then we can actually say dot triggered, and this will be called whenever the button is triggered on the frame. So if we press jump and it's grounded, then we do a jump, and they just used a physics equation for this. It's a kinematic equation, I believe. And then they're just adding in the gravity times time dot delta time, and then they're moving the player with our new player velocity that we calculated times time dot delta time. So here they're moving it for the normal movement, and then here they're moving it with the gravity and the jumping speed. So this is dedicated for the y-axis, and this is dedicated for the x and z axis. And then I actually forgot to do this, but in Awake, for our player controller, we actually have to set our controller since we don't do that. So controller equals get component character controller. So then it will have access to our character controller. And I'm just going to copy these variables and put them to the top of the class so we can be a little bit more organized. And then I added in the player controller to our player game object by just saying add component and then add in the player controller. So we can press play now, and we can actually move around. Whee! And if you move the joystick, it will move around as well. So the reason it was moving up is because the collider is not centered, so the character controller adds in its own collider. So let's center that upwards. 0.95 is a good value. And then we can press play, and you can see now it's grounded, and we can move. And when we press this button, we jump. Awesome. So now let's add in a camera follow with Cinemachine. So this is not a Cinemachine video because that's a whole topic. There's a lot of Cinemachine cameras, so this is just like the basics to get you started. So up here we're going to want to go to Cinemachine and create free look camera, and the free look camera allows you to override its values. As you can see here, it has axis controls, y-axis and x-axis. We're going to override those values, and that will shift the camera in the direction that we want it to go in. So for Cinemachine, it creates a type of camera, in this case it's free look, and then it attaches a brain. So if we go to our main camera, it attaches a Cinemachine brain, which controls the main camera, movement and rotation. So we can leave those values as it is, and we can go to our free look camera, and these are the settings to change that main camera. You can also change between Cinemachine cameras. It's a really cool system. In this case, we want to have the camera follow our player, so let's drag in our player object into follow. And then we also want to have the camera look at the player, so we can also drag in the player to the look at field. So now it's looking at that player. Not very good though, so let's change the values a little bit so they match better. So right here there's 3 rigs, bottom rig, middle rig, top rig. These are more advanced settings that we're not gonna need, so let's just focus on the middle rig. We can adjust the radius, meaning the distance to the player. So let's put it maybe to 7.5, and then let's put the height to 2.75. So you can see in our player we have the Cinemachine camera. It's an orbit camera, it's orbiting around the player. So if we go to the top, we can press solo to preview our camera, but we're getting an error, and that's because it's currently using the old input system right here, mouse Y and mouse X. So we can just remove those values and we'll be putting in those ourselves. And then let's select the game window guides. So it'll show you how the Cinemachine is currently set up. So basically this is the center of the camera. It'll try to follow the character by positioning its center to follow the character, and then it won't allow the character to go past these red bounds. And then there's some extra lines here, and those serve as dead zones. The player will be allowed to move in the dead zone, and the camera won't follow the player while it's in the dead zone. But once the player moves out of the dead zone, it'll continue to follow the player. So in this case for our middle rig, I'm just going to select an offset. So I'm gonna put the Y offset to 1.75 so it looks a little more forward. We can also change the screen Y to change the screen Y position. I'm going to set it to 0.54. You can mess around with these values. I'm not gonna set any dead zone width or height, and we can just test out how that's going to work out by pressing play. So you see we're moving and the camera is following us very smoothly, which is awesome. And you can see the camera moves up when we jump. All right, so once you've messed around with those values, let's actually do the look around. So let's right click, create C# script, camera look. Going to delete these comments. And then we want a reference to the Cinemachine free look. So at the top, we're gonna say using Cinemachine. Going to erase these 2 using statements since we don't need them. And we can also say require component type of Cinemachine free look. And so you won't be able to add this script unless you have this already attached to your game object, and if it doesn't have it attached, it will add it for you. So then we can say private Cinemachine free look Cinemachine. So we're going to keep track of our Cinemachine camera. And then we also want to have a reference to our controls. So private player input. And then I'm just going to copy from our other script our on disable and on enable. As well as the awake function. So this is just setting up the player input, and I'm going to erase this controller since we don't need it. And you don't actually have to do this. You can make a input manager, so you only have to instantiate this once, and then in that input manager you can just read those values from the manager instead of having a bunch of these everywhere. But for sakes of simplicity and time, I will just instantiate it in each script. So in our awake, let's also do Cinemachine equals get component Cinemachine free look. I'm going to zoom in so it's easier to read. And then we can delete the start. In our update, we can read in the value. So vector2 delta player input dot player main dot look dot read value vector2. And I named it delta because it's basically giving us the delta between our on pointer down and our current position. And then we can say Cinemachine dot mx axis. So we're changing the x-axis value manually, plus equals, so we're adding to that value. Let's add in the delta x times a look speed that we're going to declare right now, times time.delta time. And let's also do that, copy that to the bottom and replace that with the y right here, and then delta.y. We have to declare the look speed, so we can say serialize field private float look speed, and we can just set that to 1 for now. So all we're doing here is we're changing the Cinemachine values manually. We're adding in our delta position that we're reading in with the input, and we're timing it by look speed and times.delta time. And I'm just doing this in advance. I'm also going to multiply the x-axis value by 200. I found that to be a good value for mobile. And you can change that value. You can also mess around with the look speed variable. And there's other variables here. In the x-axis, it also has a speed that you can set, a max speed. You can set the acceleration, but I'm not gonna mess with those values. I'm just setting it in the script. So in our Cinemachine, we can just add in the look. So camera look, and you can set in the look speed however you want. And you can actually click play, and we can actually look around the player now with our mouse. And you can see that it follows this orbit, and then when you look up, it'll follow the orbit upwards. So we can just drag up, and you can see it follows that orbit. And it's actually a lot less slower on mobile, but since the mouse is so fast, it looks fast. Pretty awesome. So once you're done playing the game, just set the character controller center to 1 so it's on the floor. It was floating a little bit. Alright, and then the last thing that we want to do is change our player controller script so that it moves in the direction of the camera. So go back to player controller, go back to update, and then instead of this movement, let's actually do something a little bit different. So let's say private transform camera main, and I'm going to store the transform for our main camera. So camera main equals camera.main.transform. So it doesn't have to search the scene each time you call camera.main. In our move, we can say, with this nice, neat little trick, camera main.forward. So this is the forward position that the camera is pointing at, which is going to be the same as the player, times movement input.y. And why is it y? Well, we're using the y as our z movement, and since forward is in the z-axis, we have to multiply the movement input.y by the forward vector. And then you add in the camera main dot right times the movement input dot x. So you take the forward vector of the camera, you multiply it by your input, and then you take the right vector of the camera and you multiply it with your input as well. And this will cause it to move in the correct direction. It'll even allow you to move diagonally since it's taken into account both the forward and the right vectors. And then we can say our move.y to 0 since we don't want to move in the y direction with this statement. Alright, so now we're testing it out. So let's move around the player, and then when we start to move, the player starts rotating in that direction. And we actually want to have the player rotation match the camera rotation when we start to move. And that's pretty simple. So we can say if movement input does not equal vector2.0. So if we're moving, and let's do this at the end of everything else, then we rotate our player. The issue is if we rotate the main player, it will cause the camera to rotate along with it since it has the look at property of our player. So that's why I put in the mesh as the child so we can actually rotate the mesh and not the parent object. So let's say private transform child, and then on start we can say child equals transform.getChild 0.transform. So we're getting the transform of our first child, so this is the index 0. So this is going to be the one at the top of our hierarchy, which in this case is the capsule. You can also assign it by dragging and dropping if you make it a serialized field, but this is easier. And then we can get our rotation angle that we want it to rotate in, and we can do that with a quaternion. So quaternions manage rotations in Unity. Quaternion.Euler. So you can see here the Euler method returns a rotation that rotates z degrees around the z-axis, x degrees around the x-axis, and y degrees around the y-axis, applied in that order. So we can input our angles that we want it to rotate it in, and it will turn it into a quaternion for us, and then we can just assign that to our mesh. So let's put in a new vector 3. And the only thing we want to rotate it is on its y, because that's the axis that we want to rotate it in to look sideways. So we can already store in the current rotation for the X and the Z. So child.local Euler angles dot X. For now, I'm just going to put 0 for the Y. I'm going to change that right now. Child.local Euler angles dot Z. And then for the Y, we can just get the Euler angles of the camera. So camera.main.local Euler angles.y. So all we're doing is getting the current Y rotation of the camera, and we're going to apply that to our child. And so then we can say child.rotation equals, and then instead of just setting it directly, which we can actually lerp to it. So quaternion.lerp, so it looks more smooth. We say child.rotation since that's our current rotation. So for the lerp, we have to provide the starting point of the lerp, which is our current rotation. And then we provide in our new rotation, which is the one we just calculated. And then finally, we add in the float t, which is kind of like the speed at which it lerps. In this case, we could just do time.delta time, and then we can times it by a rotation speed, which we're going to say up here. Let me just copy in this gravity value and change it to rotation speed, and then I'm just going to set it to 4. You can play around with these values, of course. I forgot to remove this part here where it changes the forward direction of the player. We don't want that because that will mess with our rotation quite a lot. And one thing I forgot, which is why it's a little strange, it's in the canvas scaler. I had to put the scale with screen size, and let's put in the 1920 by 1080 for our reference resolution. And this will make it so that it scales accordingly. And then we can set in how much we want it to match. So in this case, I just want it to match on both sides equally, 0.5. So as you can see, the match determines if the scaling is using the width as height or height as reference, or a mix. In this case, 0.5 means both of them equally. And then another thing that I just forgot to mention was that you can also adjust the spline curvature for the camera. So right here in the Cinemachine, you can adjust that spline curvature to make it a little bit bigger or a little bit smaller. And so we click play, we can look up, we can look down, sideways, we can move with the joystick, and we can jump. Lastly, you can just adjust the UI so it can look a little bit bigger, because right now it's looking a little bit small. So you can just put the scale to 2 and 2 for the joystick, as well as the jump. You can just put the jump to 1 by 1. Alright, and then you can just say File, Build Settings, Player Settings. Here under the Player Settings, it allows you to choose the orientation that you can rotate your game. So I don't want it to be in portrait, so I can just deselect those 2 portraits. You can set your product name here, so that's the name of the app, your company name, and then you can add in an icon. There's a couple of other settings here as well. One of them that you'll need to take note of if you're going to upload to Google Play Store is the API level. They require a certain API level, and you're going to have to select that for the minimum one. And you're also going to have to select a package name. So you put in com and then your company name and then the name of your application. So we can just say build and run once you select your device here and make sure the scene is included here. Build and run. I've made a builds folder here, and you just name it whatever you want and save, and then it will build it onto your phone. Now when you export it to mobile, you can look up and down, look sideways, and then the joystick works correctly, and when you move it, it starts moving forward into the camera direction. You can also press the button to jump. You might want to make these buttons a little bigger. You can also mess around with the camera speed, the camera spline, and the camera radius. Adjusting those values will allow for a smoother transition. There's a bunch of other values such as damping, and you can just play around with those. So thanks so much for watching. I hope you enjoyed this video. I spent quite some time getting this to work, and it's still a little bit tricky, especially with Cinemachine, but I'd like to thank my patrons for their continued support. They really helped me. And if you're interested, the link is in the description to my Patreon. I have access to source code there, as well as early access to videos and exclusive devlogs for an indie game I'm making. So once again, thanks for watching. Please like the video if you enjoyed the content and subscribe to get notified on new videos, and see you next time.